Hello guys and welcome to another video on tolerance stack-up analysis with assembly shift. So here is another example of how assembly shift is incorporated into the tolerance stack-up analysis and how we can calculate certain attributes or certain specifications which can be detrimental to the function or performance of the system. So here is an example. There are three parts over here in this assembly. There are two posts. This is one post, this is another post. Two posts are assembled onto a base plate using 4 fasteners each. So this post is assembled using 4 fasteners which is having 4 clearance holes. So there are 4 clearance holes on the post as well as the bottom plate. So these are 4 floating fasteners. Similarly, there are floating fasteners over here and 4 clearance holes on the post and 4 clearance holes on the back plate. Now the problem definition is we want to find out what is the maximum span, the maximum distance between this point and this point in the worst case in assembly. What is the maximum span possible at the tip? So we will do a worst case tolerance stack-up analysis and find out this specification. The first thing is we will have a look at the drawings. What is the data available with us? So these are the drawings of the back plate. This is the drawing of the back plate and drawing of the post. So that is a central hole, and then there are 2 patterns of holes on either side, and these 2 patterns of holes are dimensioned and toleranced as shown. So 18 plus or minus 0.1 is the center to center distance between these 2 holes. 24 plus or minus 0.1 is the center to center distance between these 2 holes in the vertical direction. And the size of the holes is 4.5 with a size tolerance of plus or minus 0.1. And this is the location of the patterns. So the patterns, this pattern and this pattern are located from the central locating hole at 49 plus or minus 0.25 on either side. So this data will be sufficient to calculate the stack on the plate. Now this is the drawing for the post. The post is having the same pattern of 4 holes, 4 clearance holes, and the dia is also the same. The specification of the dia and the tolerance is also the same on the post for the 4 clearance holes, and this indicates the location of the center axis of the post with respect to this hole. So 9 plus or minus 0.1 is the location of the center axis of the post with respect to this hole over here, which is part of the pattern. And in the other view, there is a specification for the angle of the post with respect to the base as well. So the post should have, it has a basic dimension angle of 90 degrees, and that angle can vary plus or minus 0.5 degrees. So it can tilt this way, it can tilt the other way also. And the size of the diameter of the post is 12 plus or minus 0.1, and the length specification of the post is 60 plus or minus 0.25. So these are the data which we have, based on which we can calculate and we can do this tolerance stack-up analysis. So the first important step in any tolerance stack-up analysis is to create the loop diagram to understand the assembly, to understand the sources of variations, and to stack all of those sources of variations into a loop diagram. That's the first most important step. So here is the loop diagram. We will go one by one. So the red arrow indicates the gap which we need to calculate, A to B. Let's start from A and go towards B. So this is the edge of the post. So from that we are going towards the center of the post, center axis of the post. Before that, there is a variation in the angle of the post which will cause the basically increase in the gap. That variation in angle of the post will cause an increase in the gap, which is accounted by specification number 1. So specification number 1 is the distance increase in the span between the 2 posts due to the variation in the angle of the post, which we had seen earlier, 90 plus or minus 0.5. So that's the first type of variation. Second type of variation, which is the second specification, is the variation in the diameter of the post. So that we can take directly from the drawing of the post. The diameter of the post varies and that variation is captured here. Now we go towards the right. So from the center axis of the post, we go towards the location of the hole. So that specification we had seen 9 plus or minus 0.1. So that is accounted over here in specification number 3, which is basically the deviation in position of the post with respect to the hole over here. The deviation in position of the post. That is specification number 3. Then there is an assembly shift which is involved, which is basically shown over here. So the post can shift towards the left. That is called as assembly shift. When it is being assembled, it will not be at the center all the time. So the worst case is it moves towards the left, and there is an assembly shift, which is denoted over here by these fasteners which are contacting on the right. So that is accommodated in this specification, which is specification number 4. That is the assembly shift of this post with respect to the bottom plate. Then the location of the pattern of 4 holes with respect to the center hole is the specification number 5. Similarly, it's a mirror image on the other side. So the location of the pattern of the 4 holes with respect to center hole is specification number 6. Specification number 7 is again assembly shift. This post moved towards the right. So assembly shift again towards the right. This is moving towards the left. And then the specification of location of the post with respect to this hole. So the post location with respect to the pattern of holes is 8. And then we are going towards the left again. That is the diameter or radius of the post, variation in size of the post. And then specification number 10 is again the variation in the gap or the span because of the angle deviations. So there are 10 sources of variations, 10 types of deviations which can occur in this loop diagram, which we will see one by one, and we will list them down and calculate the maximum span. So first we will investigate 1 and 10, which is the deviation in the span because of the angle. Before that, let's just list down the 10 types of variations over here. So the first variation is deviation due to angle variation of the post. Second specification is deviations in size of the post, which is radius. Third is deviations in position of the post with respect to the holes in the pattern. Fourth one is assembly shift between plate and post. Then fifth is the deviation in position of the pattern of holes from central reference hole, and sixth is the same on the right hand side. Seventh is assembly shift between the plate and post on the right hand side, and eighth is deviation in position of the post with respect to the pattern of holes. Ninth is deviation in size, which is the radius of the post, again over here 9, and 10 is again angle variation of post. Now let's calculate for the specification number 1 and 10, which is the deviation in the gap due to the angle variation of the post. So the angle variation is as per the drawing as shown over here, 90 plus or minus 0.5 degrees. And an important factor to consider is that the angle variation will cause maximum difference in span at the longest dimension of the post. That means the post is having a height of 60 plus or minus 0.25. When it is at 60.25, that is the maximum possible gap which will be created. So this distance, basically we are creating a right angle triangle by connecting this straight line with this inclined line of the post, and this value of x will be the highest when the post is longest. So that we are calculating. So for 0.5 degree angle, and adjacent side is 60.25, which is this green color line, that is the height of the post, and this is the inclined line which indicates the deviated post in the angle to the maximum. Then we are calculating the x value. So x value will come out to be 0.526, and this will be plus or minus 0.526. It can go either way. It can go towards out, it can go towards in. Now let's calculate for 2 and 9. 2 and 9 are identical variations. So these are deviations in size, that is the radius of the post. It is nothing but the deviation in the radius of the post. So from the drawing we have this value 12 plus or minus 0.1, which shows the variation in the diameter of the post. We just make it into half, which because we want radial size variations. So the specification is 6 plus or minus 0.05 for 2 and 9. Then we look at 3 and 8. So what is specification number 3? 3 is the deviation in position of the post with respect to the holes in the pattern. So with respect to the 4 holes in the pattern, how is the post located in the horizontal direction? That is given by this specification, 9 plus or minus 0.1. So as it is, we can take that value, which is 9 plus or minus 0.1 for 3 and 8. The next type of variation is the assembly shift between the post and the plate on the left hand side and the right hand side, which is specification number 4 and specification number 7. So as you can see in this top view as well as in the side view, you can see the variation in this is a cut section view which shows the variation. So basically the plate is moving towards the left hand side over here. This plate is moving towards the left and this plate is moving towards the right, which basically contacts the fastener over here and here and over here and here. So because of that, you can see that there is some amount of assembly shift which has taken place, and that assembly shift is calculated over here. So this is the situation in which the fastener is at the center of both the clearance holes, and this is a situation in which it contacts the edge of the post clearance hole. So you can see how the assembly shift happens. This is the assembly shift in action. Moves towards the left. So how much does it move towards the left? How much can this post move towards the left? How much can this post move towards the right? So that is nothing but this value, 0.3. So the total size of the hole is 4.6 over here, 4.5 plus point. We are taking the largest hole. So assembly shift is highest when hole is largest and the fastener is smallest. We are considering the smallest fastener diameter to be 4 mm and we are considering the largest hole diameter to be 4.6 mm based on the drawing, 4.5 plus 0.1. So 4.6 mm is the largest hole diameter. The size of the fastener is 4 and the gap is 0.6, and out of that this 0.3 is the assembly shift. This 0.3 is the gap in the plate, which will remain the same because the assembly shift of the plate does not matter. The assembly shift of the post matters more. Hence we are only looking at this one, which is 0.3. So assembly shift will be plus or minus 0.3 mm. So it can move towards the left, it can move towards the right. We'll keep the specification plus or minus 0.3 mm. Again, what happens is the posts, they move outward, they shift in the assembly and the fastener comes into contact with the edges, and when that happens we can calculate the assembly shift which has happened, which is calculated based on this. So the largest hole and the smallest fastener, that is a gap of 0.6 mm, and out of that 0.3 is the shift of the post, that is the assembly shift. And then finally we calculate the deviations of 5 and 6 specifications, which is shown over here, which is nothing but the location of the two patterns of holes with respect to the central locating hole, which is 49 plus or minus 0.25 and 49 plus or minus 0.25, that is 5 and 6. Deviation in position of the pattern of holes from central reference hole. So specification number 5 and 6 is 49 plus or minus 0.25. Now we have the specifications from 1 to 10. We can tabulate them and we can assign the signs plus negative or positive depending on the direction of the arrows. So the arrow going from left to right is positive. The arrow going from right to left is negative. Based on that, the signs of the dimensions will be allocated. So here is a table. Specification number 1 is the angle variation of the post causing the increase in span. That will be having a value of plus or minus 0.526, which has been calculated. Second one is the radius of the post, which is this arrow over here, yellow arrow going towards the left. Because it's going towards the left, it is negative, so minus sign, minus 6. Tolerance is plus or minus 0.05. Then we are moving towards the right, which is positive. So specification number 3 is the position of the post with respect to the holes in the pattern. And that value is 9. Tolerance is plus or minus 0.1. Then we have the assembly shift, which is specification number 4. And that does not have a dimension, it only has a tolerance plus or minus 0.3. Specification number 5 has a dimension and tolerance, and it is positive, which is the position of the pattern of holes with respect to the center hole. Similarly, specification number 6 is the position of the pattern of holes with respect to center hole on the right hand side. Same specification, 49 plus or minus 0.25. Then we have the assembly shift, which does not have a dimension, only tolerance plus or minus 0.3. And also next, position of the post deviation, that is specification number 8 plus 9 plus or minus 0.1, and then the size deviation, specification number 9 minus 6. Again over here the arrow is going from right to left, which means that it is negative, so minus 6 plus or minus 0.05. Again we factor the angle variation of post, which is plus or minus 0.526. Now we add all of the dimension values, minus 6 plus 9 plus 49 plus 49 plus 9 minus 6, we get 104, and we add all of the tolerance values. Add up all of the tolerance values, which will give the stack up. So the specification in the worst case for the span is 104 plus or minus 2.202. So the maximum possible span will be calculated by adding the tolerance value to the dimension, which is 104 plus 2.202, which is 106.2, which is the maximum possible span at the top edge of the posts. Thanks a lot for watching this video. I hope this video has been helpful and educational. Please do like, share and subscribe, and also comment on what kind of videos would you want to see in the future. I have been creating these types of videos, and I have many other videos on GD&T, general design engineering, concept development, etc., covering the whole array of topics in design engineering. So check them out on the channel. Thank you.